Welcome to my channel once again. Good morning, good evening, good afternoon, wherever you are. Welcome once again. In this video, we will explore laws of indices. Now, we are living in a world where order must be maintained. In order for order to be maintained, we are governed by rules. Drivers cannot just turn anywhere they wish, and people cannot just go anywhere and shout as they wish because we are governed by rules in order to maintain order in this world that we live. Similarly, in mathematics, mathematics is about order, and there are rules that govern how we work with powers. And speaking about powers, let us look at what we have here. Here we have an expression 3x squared. The number 3 is what we call the coefficient. The x that we're seeing here is what we call the base, and the 2 that we're seeing at the top is what we call the power. Now this power here can also be called exponent, and it can also be called index, singular index, plural indices. And working with powers, we have some rules that we have to abide. In this video, we will look at 3 of the laws of indices. In part 2 of my video, we will explore some other laws of indices. So likewise, we have x to the 4th power, where x is the base and 4 the power. If we look here, we have another expression here, minus 7y to the 3rd power. Minus 7 is what we call the coefficient, y is the base, and the power or exponent or index 3. Now if we look at x to the 4th power, this has a coefficient of 1, but we're not seeing it. So we will look at the first rule. Now here we have x to the 2nd power multiplied by x to the 3rd power. We would like to simplify this expression, but hey, we see a base x. Here we have base x, so the bases are the same. Let us expand x to the 2nd power. Now x to the 2nd power is simply x multiplied by x. The number 2 here tells you that you multiply the base by itself 2 times. Likewise, x to the 3rd power means x multiplied by itself 3 times. So we write x by x by x. So we have 1, 2, 3, 4, 5. 5x. So this here we write as x to the 5th power. What does this mean? It means that x is multiplied by itself 5 times.
Hey, but teacher, there must be a shorter way to do this.
Vladimir, I'm on air. Vladimir, introduce yourself to him.
Hello, my name is Vladimir, and today I will be helping my teacher with laws of indices.
Okay, good. Thank you, Vladimir. Now, there is a shorter way, as you said. Instead of expanding this, and this will take a lot of time because if we have x to the 6th or 7th power, then we have to multiply x by itself 6 or 7 times. Multiply by x to a greater power, it will be a lot of times. So, this is what we will do. Since this base and this base is the same, I keep my base. Vladimir, we have the power 5 down here. If I give you 2 and 3, and I would like to have 5, what will you do with 2 and 3 in order to get 5?
Well, teacher, I add 2 to 3. 2 plus 3 equal 5.
Good, wonderful. So 2 plus 3, 2 plus 3, and here we have x to the 5th power. And if we notice, it's the same. And this brings us to our first rule. Our first rule states that when the bases are the same, we simply add their powers rather than expanding it like this. So let's do a next example quickly. Now working with indices, very good. So here I have 3x to the 3rd power multiplied by 2x to the 2nd power. What we do here? Alright. So the first thing we would do is to multiply the coefficients. So here we have 3, the coefficient there is 3, the coefficient there is 2. So we multiply 3 by 2, 3 to 6. And Vladimir, what is the base here?
The base is x.
Good. And what is the base here?
It is also x.
Good. So since the bases are the same, I just simply keep the base and I add their powers. So we have 3 plus 2. And this will give us 6x to the fifth power. Very, very easy. So we will take that off. Just to recap the first rule states that when the bases are the same, when multiplying expressions, we simply keep the base and we add their powers. Alright, now let us look at another rule. Suppose I have x to the fourth power divided by x to the second power. What we do here? Now, if we expand this, this is the same as x multiplied by x multiplied by x multiply by x. Now x to the fourth power is saying that you multiply x by itself 4 times. 1, 2, 3, 4. And what we will do now, divided by x to the second power. Vladimir, help me. X to the second power, what do we write? As a teacher, we write x multiply by itself 2 times. Good, wonderful. Let's do some cancelling. X will cancel with x will cancel with x. So what we have left here, by x, we have 2x here. So x multiplied by x will give us x squared. But there must be a short way in order to simplify this expression. Because if we have x, instead of x to the fourth power, if we have x to the 75th power, then we will have to write x multiplied by itself 75 times. Likewise, instead of x to the second power, suppose we had x to the 31st power, then we'd have to write x by itself 31 times. So there must be a short way in order to simplify this expression. So this brings us to the second rule. The second rule states that when the bases are the same, when dividing expressions, then we subtract their powers. It is always top subtract bottom. We have 4 subtract 2. Here, our answer is x to the second power. If we notice that this is the same as that. The second rule, let us recap again. When dividing expressions where the bases are the same, we simply subtract their powers. Even if the greater number is at the bottom, we still have to subtract bottom. We will end up with a negative power. And in part 2 of my videos, we will baptize negative powers in order to make them positive. So be sure to look at that video when it is uploaded. Alright, so let's do another example with this to be sure what we have to do. Alright, so the next example. Suppose I have 12x to the sixth power divided by 4x to the third power. What we do here? Coefficient of x to the sixth power is 12. The coefficient of x to the third power is 4. Now if we look here, the base and this base, they are the same. This is what we will do. 12 divided by 4 will give us 3. Hey, but teacher, we have to keep the base when it is the same and subtract their powers. Good, wonderful. Wonderful. So we keep the base and then we subtract the powers. Top power is 6. Subtract the bottom power, which is 3. So here we have 3x subtract 3 will give us 3. The answer here is 3x the third power. Now remember, when working with powers, there are rules. We just cannot pass a power through a window or just make it disappear like that. There are rules that govern what we do and how we do things in working with this beautiful subject, mathematics. Right, so let us go on to our next rule. Next rule is what we call the power of a power rule. Now, if I have x to the second power, then we have a power outside of the brackets 3. What does this mean? No, x to the second power means x multiplied by itself. X to the second power raised to a power 3 simply means x to the second power multiplied by x to the second power multiplied by x to the second power. X to the second power multiplied by itself 3 times, and that is what the 3 outside the bracket means. Let us simplify this. According to the first rule says that when the bases are the same, we keep the bases and we add their powers. 2 plus 2 plus 2. This will give us x to the x power. But there must be a short way. There must be a rule in order to help us to work and to simplify this expression in a much shorter time. So here we have 6. Two numbers at the top, the inner power is 2 and the outer power is 3. How you be able to get 6 from 2 and 3? I add 2 to 3, I get 5. If I subtract, I say 2 subtract 3, I will end up with -1. So the only way I can get 6 with 2 and 3 is to multiply. So that brings us to our third rule. We're working with powers of powers. We call this a power of a power rule. Then we multiply the inner power by the outer power, or the outer power by the inner power. It doesn't matter because in this case it is commutative. The order doesn't matter. So here we keep the x and we multiply inner power by outer power. So here our answer is x to the 6th power. And if we notice that this is the same as that is our third rule. Inner by outer, inner by outer, inner by outer, inner by outer. Good. We will recap in a moment. Let's do one more example. Suppose we have 3m second power, all of this raised to a power 2. What do we do here? Inner power by outer power, and we must account for all the powers within the brackets. M has a power 2. What is the power of 3? Power of 3 is 1. I don't see a power there, but it's 1. And in another video, we will explain these things in detail. Why we do not write it, and so on. So here we have our powers accounted for, 1 and 2. So we said that we multiply the inner power by the outer power. So this is what we will do to simplify this expression. 3 inner power 1 by outer power 2. Inner power 2 by the power 2. This will give us 3 second power, 4th power. What will this give me now? Common mistake. At this point in time, let me identify this mistake that students make. Students often multiply the base, the power, say 3 times 2. Remember, this means 3 multiplied by itself 2 times. 3 multiplied by 3 multiplied by m, 4th power. 3 multiplied by 3 will give me 9. Write my m and I have my answer. Before we close this video, you may be wondering, can we expand that? The same answer. Yes, of course. The question that we were given here, 3m squared raised to the power 2. What this simply means, look down here, this means 3m multiplied, this is 3m squared, multiplied by 3m squared. Simple. Again, we multiply coefficient by coefficient. 3 multiplied by 3 will give me 9. Okay, this base and this base is the same. So I keep my base and I add the powers. 2 plus 2. So we have 9m, the 4th power. And if we see, this is the same as next video, we will explore rules. We will baptize negative powers in order to make them positive, and we will resurrect powers and so on. So be sure to view part 2 of my videos on laws of indices. Now, isn't mathematics fun and beautiful? Now, please consider subscribing, part of the wonderful online community, and give the video the thumbs up. I agree that mathematics is the easiest subject in school. It is the best subject. I am promoting this subject because I'm teaching it. Students, believe in yourselves and just do what you have to do, and you will succeed. Here wants to say something. Hey, viewers and subscribers. Here to subscribers. Subscribers, oh, whatever. Sure to subscribe and like my teacher's video. For watching. It's Vladimir saying bye. Goodbye till part 2 of my video.